Hello, welcome to this episode of Learning How to Code. Now, to those who've been wondering why I've been gone, the main reason was writing scripts are boring and writer's block. One, because I was really trying to figure out what was next to teach, but what I found was like we had learned enough of the basics that there really wasn't anything really big to teach besides learning really how to use everything, because really everything we're doing is some type of advanced version of the basics that we just learned. Objects are nothing more than a collection of variables and methods. The ternary operation is nothing more than a simplified version of the if statement. Switch cases are a simplified version of the if statement. Lists are nothing more than advanced versions of arrays. And so I decided that instead, what I was going to do was I was going to move more to project based, learning. Since we already have all the basics down from this point forward, what I want to do is I want to just go through a list of projects, and I'm just going to explain using everything we've learned in the previous videos to explain how did I implement what this project is asking me to do. And then, go into detail whenever something new comes in. But when it's something is old, like variable types, for loops, conditional statements, I'm not gonna go too deep into those. That's what those previous videos are for. This is just to explain how to use all these tools you've gained to solve a problem, and how to read a problem and then use it to solve a problem. So in this case, the problem we're dealing with is 100 doors. Now, so let me read this description and then I will summarize it for you. And if you want to go to the website and see it yourself, and on the website there are multiple solutions for many different types of programming languages. You don't need to do this in C sharp. You can kind of convert my code into whatever code you want. But if you want to see, how other people answered it and discuss with other people about it, go to this website or do it in the comment section. Now let's read the description. There are 100 doors in a row that are initially closed. You make 100 passes by the doors. The first time through, visit every door and toggle the door. It basically, what they're saying when they say toggle the door is they mean if the door is closed, open it. And if it is open, close it. Now, once you've gone through every single door, go all the way to the beginning, start at the second door and visit every second door. And then the third time, start at the third door and visit every third door until you visit all 100 doors. And if you don't completely understand, if you're still a little bit confused, think of it if we only had 6 doors. No, let me get simpler. 5 doors. No, let me use 10. Yeah, I know it's weird. I'm going to use 10. So, the first time we go through the 10 doors, we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we went through all the doors. Then we go 2, 4, 6, 8, 10. We've gone through every second door. Then we go through every third door. 3, 6, 9. Now we go through every fourth door. 4, 8. Then we go through every 5 doors. 5, 10. Every 6 doors, 6. Every 7 doors, 7. Every 8th door, 8. Every 9 doors, 9. Every 10 doors, 10. And that's all. And now you can just kind of expand this to 100. So, if we're going through every 9 doors, instead of just being 9, when we only have 10 doors, when we have 100 doors, 9 becomes 9, 18, 27, blah, 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 81, 90, 99. Oh yeah. I was going to say 36, 45, 54, 63, but, we don't need those. You understand what I'm saying, 72. We go through every 9 doors, and that's all this program is going to do. Now, what I want you to do is I want you to kind of read this, pause this video and maybe take a minute or two to just kind of think about how you would use the tools we used in the previous episodes to previous videos to solve this problem. So some hints are 100 doors in a row. So that kind of sounds like we have a collection of doors. And these doors are independent, but we're gonna kind of, we're gonna have them all kind of in the same place. So it's like a collection. They're all initially closed. So it seems like they're in some type of initial state. They seem to only have two possible states. They can either be opened or closed. So that sounds like a variable we use. And you seem to go through them in a count controlled, okay, that was a little excessive, a count controlled manner where we're going through the first, then the second, and the third. Seems, so it kind of sounds like you're going to be doing a lot of stuff over and over again. So there seems to be a certain structures you can use, so you don't really need to write each line of code by hand to accomplish this. And, with I guess next time I should say, I'm going to give you some hints if you don't want me to say anything. The next time I'll make sure to say hints are coming, hints incoming or something. But think about it for a minute or two and just pause the video for a minute or 10 minutes, however long you want, to try to answer the problem yourself and compare it to my answer. Okay, so I'm assuming you pause it and now we're done. So let's go to my program and we can see, as I said, it's some type of collection. So as you can see, I have created a array of 100 booleans. Now, you can kind of understand why I say 100 booleans, and you can see that the array, the variable's name is called door, which stores 100 booleans. But now the real question is, why am I using booleans? The reason I'm using booleans is because booleans, like doors, can only be opened or closed. A door can be open or closed, and it can never be anything else. And so it's natural that I would want to use a variable that is as close to my problem as possible. In this case, a boolean. And that's why, I'm using it. Now, if you remembered in previous videos, I would have talked about it, how variables, when they're just declared, they don't have anything inside of them. Now, I don't remember off the top of my head if C# initializes the, array values, but just to be safe, I'm using a special method called fill, which pulls from the array class, which will make it so that every door in doors is false. So now I know for a fact that every single one of my doors is closed. And I forgot to tell you that whenever something is true, that means that door is open. And whenever a door is false, that represents the door being closed. Now we saw that we're going to skip certain doors, and the door we happen to skip also the door we're starting at also tells us how many doors we have to skip before we toggle it. In this case, we're starting from door 1, and so we're going to skip no doors because we're going to go through every single door. There's never going to be a door in between us. And because we know there are 100 doors, we need to skip at least 100 times to guarantee that we go from door 1 to door 0. Which is why we have that less than or equal to. Now, if you don't know, a quickie into how a for loop works. A for loop works by initializing and declaring and initializing a variable. In this case, our variable is skip. Then having some type of conditional statement. In this case, our conditional statement is skip is less than or equal to 100, which means that if skip is 99, which is less than 100, it passes this test. And once it passes this test, it's going to do some work inside of its parentheses. Right here, it's going to do some work inside of here. And then once it gets to the end of these parentheses right here, it's going to jump back up here and it's going to increment itself, which means, or it's going to use skip plus plus, which just means whatever this variable is, increase it by 1. So if skip is 1, 1 now becomes 2. And then we're going to do all the stuff we just did again. In this case, now, we're going to see is 2 less than 100. Obviously, that's true. And then we're going to go inside of here to the end and repeat that. Now, I'm not going to completely repeat what I just said for skip doors. You already know, but just understand that there's a little twist happening right here. If you remember properly, all arrays in C# start with 0 because that's how arrays work in C#. So to kind of make it easier for you to imagine what I'm talking about, in case you're still a little iffy, imagine we have a box with half a dozen donuts. Now, normally, if we were to give each of these donuts a name so people could easily pick what they want, we would give them numbers and we'd start from 1. So we'd say donut 1, donut 2, donut 3, donut 4, donut 5, and donut 6. And this naturally maps to first, second, third, fourth, fifth, and sixth. So when someone says, give me the third donut, they also mean give me the donut with the name number 3. However, an array starts counting from 0. So you can imagine like a donut box that instead of starting from 1, you said start from 0. So instead, you name each donut 0, 1, 2, 3, 4, 5. That means when someone asks for the third donut, you're not going to give them donut 3, the donut that is in the 3 spot. You're going to give them the donut in the 2 spot because 0, 1, 2. You can see, let me put this in. I have my example here. It messed me up because it got changed somehow. But you can see that 1, 2, 3, because we start from 0, it ends up with 3 being, the answer. And okay, so so I don't know what happened there. Some of my code got deleted. I was wondering what was happening. Okay, that's good. So you can see that when we start from 0, 0 gets treated as the first spot, 1 gets treated as the second spot, 2 gets treated as the third spot, 3 gets treated as the fourth spot, and 4 gets treated as the fifth spot. So when someone asks for the third donut, they're asking for the donut at spot number 2. But when someone asks for the donut at spot number 3, they're actually asking for the fourth donut. And that is why we have skip -1, because we must start at 0, because 0 is the first. And that is also why we have door less than 100 rather than less than or equal to 100, because 100 is actually if we ask for a door that at 100, we're actually asking for the 101 door or the 101st door, which we don't have. We only have 100 doors, which means we need to stop at 99, because 90, which is how this works. 99 will always be less than 100. There's no number between 99 and 100. That is an integer and a whole number that can cause this test to pass. So it's safe. So this will stop at 99. It will do all this work here, and then it will use the skip. In this case, the skip is 1, and we start at 0. So we'll do 0, 1, 2, 3, 4. We'll go up here. We'll then increment the skip to 2. This means now our starting door is 2 minus 1. So we'll start at the 1 spot, which actually happens to be the second door. And then we'll do door plus equals skip, which means we'll go through every second door. So we'll go through the second door, then the fourth door, and then, the 6th door, the 8th door. And we'll keep repeating that over and over again. And you can kind of see. And now, I'm kind of explaining what's happening with this code. So the code below, as an array, is accessing one of the booleans in the array and then flipping or toggling that variable's value. I really should use an apostrophe because it owns that value. And so so in this case, let's say we're starting with a skip 1 and we just started. So this is skip 1 and we're at door 0, which is also the first door. Since that door has an initial value of f, what we're going to do is we're going to go to that spot and we're going to toggle it. And so, let me use my example right here. So let's say we're trying to toggle door 3's content. Well, right now, door 3's content is true. Now, as I said before, booleans have 2 values, which is true or false. And so what we're going to do is we're going to use a special property of booleans, which is the not logical, which is a special single operand operation called logical NOT. Now, an operation is something you've seen before, you just haven't heard that name, heard it told in that name. Now, an operation is like plus, minus, division, and subtraction. But unlike, those operations, those operations require two operands. So to add something, you must have 2 plus 3. You can't just do 2 plus. That doesn't mean anything. You need to do 2 plus 0, 2 plus 3, 10 times 5. 10 divided by 4. All of these require 2 operands. Logical NOT only needs a single operand. Now, in our computer, this is represented by using an exclamation point to tell the operand to be not the operand. So when we say not door3 content, we're saying not true. And since it can only represent 2 values, which are opposite of each other, not true is false. So all this code is doing is it's going to a specific door indoors and then saying, whatever you are now not that. So since we're in the beginning, this door was false, it's now not false, which is true. And that's just all. And then then it just goes through. And if we did it, like say with, I don't know, let's say 10, you would, it would flip it and do its thing. And now I'm just going to show you how everything looks. Don't worry about this. This is just code to let us see what's actually going on inside the array. So we can actually see what's inside of it. And I'm starting the code, and hopefully the image will show up this time. This was a long video. Let me restart it. Sometimes come on. Okay, there it goes. And now you can see that it's printed out our contents. Now I want you to know, and I bet y'all wondering, how do we check if our answer is correct? Well, what we do is that this problem has a special optimized solution. When you do this problem, it just happens to be that every open door is a perfect square. Now, what a perfect square is some whole number, some positive whole number, that when you take the square root of it, it is equal to another positive whole number. For example, the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. The square root of 49 is 7. The square root of 64 is 8. The square root of 81 is 9. And the square root of 100 is 10. So what we should expect to happen is that 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100 to all be true, because that means the door is open. And if we go through this, we see that it is. So 1 is true, 2, 3, 4 is true, 5, 6, 7, 8, 9 is true. And then we're gonna go back here to that's 4. So 14, 15, 16 is true. Go down to 26, 25 is true. Go down to 35, 36 is true. Go down to 46, 47, 48, 49 is true. Go down to 59, 51, 52, 53, 54, 55. Wait, what? So that's 49, 59, 60, 61, 62, 63, 64. Sorry, I don't know what happened to my counting there. Somehow 59, and then you go up by 1 and you go back to 50, I guess. So 64, and then we go down to 74 and go down again to 84, 83, 82, 81. Yep, that's true. Go down to 91, 92, 93, 94, 95, 96, 97, 98, 99, 100. And we see that the code is working perfectly and properly. Hopefully, your answer matches my answer. And if it doesn't, you look through my code and see, what you did wrong, maybe how you could make it simpler. And, I'm just gonna kind of close it to maybe make it a little bit easier. And don't worry, I will have it on the GitHub. But I'm just going to get rid of some of these comments so maybe it's a bit easier for you to see everything at the same time. You can see that this is a very small piece of code. Basically, very little is needed for it to get the job done. This is all the code. This is everything that happened. And I'll put the comments back in so you can have that ready for GitHub so you can look at it. And I hope you enjoyed this video. Please leave a comment telling me if you like this new format or if you feel that maybe this format doesn't work. I was going too fast. I need to give better explanations. Or, maybe I spent too much time explaining stuff that you already understand. And I bet some of you are wondering what this is. We'll talk about this in another project. But, please, because I see, some people are watching. I don't know if you're just opening and then leaving. But if you do happen to stay, please, leave a comment. Tell me, what's going on. Tell me, give me an idea of what I should do to do better. I really want to know what I can do better. Anyway, thank you for watching. Thank you for your time. Have a great day. God bless. Bye.